Sparkle. I have been in this industry for around 15 years. Okay, let me know when can I start.
Yeah, you can go ahead whenever. You can share your screen, and then we'll make sure everyone can see your screen.
Okay, please confirm you can see my
Yes.
screen.
Yes.
Okay, awesome. You are seeing the full screen? All good?
Yep.
Okay, so let's get started. Um, this particular session is about becoming a data engineer, what skills, mindset, and industry expectation is required to become a successful data engineer. I work very closely with data engineers, software engineers, data scientists, and product managers as part of my role. And I also interview and hire a lot of engineers for data focused role. One thing I mostly noticed very consistently in this, most students don't struggle because they lack ability. They struggle because data engineering is often explained in very confusing ways. It usually described as software engineering plus SQL or Python or data visualization, or probably reduced to a list of a lot of tools like you have heard of Tableau, Power BI, Spark, Snowflake, etc. However, this framing is why many early career professionals feel lost when they try to enter the industry. Tools change all the time. Ever since I have joined this industry, for the same thing, I have seen hundreds of tools. So tools are not what define this role. What what makes sense is how you think about data systems, how you reason about correctness, scale, and impact. So, today's session is about helping you build that clarity. We will talk about what data engineering really means in practice, how it's different from software engineering, and why it has become so critical in today's AI world, and how you can intentionally build the right skills, mindset to meet industry expectation. I am also going to share a framework that I use myself when I think about growing strong data engineers, so that by the end of this session, you will walk away with a clear path, some links that you can practice on, that you can read about. And so, before we begin, feel free to jot down any questions as we go. I will leave some time at the end to discuss them. So, with that, let's get started. Okay. Let me move. Can you see my next screen? So the next screen shows what data engineering really is. It's not about moving data from one place to another. If that's all it was, this would be solved problem. Data engineering is about building systems where data remains correct, consistent, and trustworthy over time, even as everything around it changes. And that overtime part is the key thing people underestimate. In industry, upstream team changes schemas all the time, data arrives late or out of order, business logic evolves, pipeline partially fails, and historical data needs to be recomputed all the time. Mostly daily basis or weekly basis, I have seen in my role over the years. So, your job as a data engineer is not done when a job succeeds. Your job is done when people can trust the numbers they see and make decisions without second guessing the data. If leadership spend times debating whether a metric is correct instead of acting on it, that's a data engineering failure. The output of data engineering is not pipelines or dashboards. The output is decision grade data. Everything else we'll talk about today flows from this responsibility. So, why software engineering is different from data engineering? Now that we have defined what data engineering actually is, why can't people think, why can't I approach it in the same way I approach software engineering? The core difference is not language or framework or the scale. The difference is what you are responsible for being correct. In software engineering, correctness is scoped to a request or to a user clicks a button, an API is called, a response is returned. The inputs are generally well defined, what you are going to receive, and also outputs are immediate and defined, that what output you are going to get and it's immediate. And whenever something breaks in software engineering world, the feedback is fast, alarms are reliable, responsible, and everything is visible from that point of failure. However, in data engineering, correctness is scoped to decision. Output of your work is not a response, it's a number, a data set, or a signal that might influence your business strategy, financial planning, experimentation, automated systems like AI. So, those decisions don't happen at one moment in time. They happen repeatedly over days, weeks, and months. And that is where the mindset really diverges. In data engineering, input evolves, assumptions change, business definitions shift, and historical data gets revisited, recalculated, and most dangerous part is that feedback is delayed or invisible. For example, you are capturing a data in a real system and you are running a batch processing job. Once you receive data and you process, while when you generate output, it's already delayed by your processing time, your collection time, and when you get the data, it's already delayed by several hours or might even be days, right? And there is no way to say if this data is correct or not correct. The output is data. So you will not get an error message if your pipeline is successful but the data is wrong. So capturing metrics as part of data engineering pipeline is very, very difficult. So nobody gets an error message when your metric is slightly wrong. Say the data that you received today is 15% higher than what you usually get, yesterday or, over the period of several days. How would you calculate whether your data is correct? Something went wrong in your pipeline or your source is corrupted. The only thing that you get to see is there is change in your data, right? And this data people take to make decision, they need to make the decision with confidence. That means a data engineer is not just asking, does this work right now? They are asking, will this still be correct when the data changes? What happens when assumptions drift? How will we know if this is right or wrong? This is what changes from software engineering to data engineering. This is why data engineering requires a fundamentally different mindset. You are not optimizing for fast feedback, you are optimizing for long term trust. And once you understand that responsibility, everything else about the role starts to make sense, including why data engineers worry about things that haven't happened yet. So, once we understand that difference in responsibility, the next question becomes what actually goes wrong when you apply the wrong mindset? Most data systems don't fail by crashing. They fail by continuing to run and producing believable but incorrect results. Your job succeeded, your dashboard is refreshed, everything looks healthy, but the data is wrong. This is what makes data engineering uniquely dangerous. Green check marks, system health, they don't mean truth. As a data engineer, we are responsible for validating the outcome, not just execution. Silent failures are far more damaging than loud ones because they erode trust slowly and invisibly. This is where many early career engineers struggle. They trust success signals instead of questioning the results. I'll give you another example. how the mindset matters here. So I'm giving you a DAO example. DAO is basically daily active users. Imagine a company reports daily active users every morning from a software perspective. The events are emitted, pipelines run, tests have passed, job succeeded. But from data engineering perspective, some events arrived late. Some users generate duplicate events, time zone shift which day activity belonged to, and some backfills has rewritten historical data. Some upstream team change the event definition. So there is schema mismatch. Nothing crashes, no alerts fired, but your number drifts. The down number that you see slowly drifts, and that is how two dashboard disagrees. Software engineering dashboards say everything looks good, all the data is present, no pipeline failure, health is green, but the number differs, right? And when the leadership sees two different metrics, they wonder which number is right. And this is how trust erodes. Code is correct, data is still wrong. And this is why data engineers care so deeply about edge cases, quality checks, validations, historical consistency. Okay, so given everything we have talked about so far, the data engineer mindset starts hopefully to make sense to you. A good data engineer assumes data is wrong until proven otherwise. Not because we are pessimistic, but because we understand how systems fail. They're designed for failure, not success. They prioritize correctness over speed. And they think in systems, not scripts. Data engineers care deeply about downstream impact because once bad data escapes, it's very hard to put the trust back. The mindset shows up everywhere in design reviews, in production decisions, and very clearly in interviews, right? So now let's talk about why it matters more than ever now in AI era. AI did not make data engineering optional. It make it critical. Now we need more data to make data driven decisions, and because of that data engineers are heavily relied upon to provide sufficient and correct data. Most AI systems don't fail because models are weak. They fail because the data feeding them is late, biased, incomplete, or inconsistent. So, data engineering sits upstream of data science, product decisions, any partner teams who are going to depend on your data. All the business decisions depend on data engineering outcome. If your pipelines are unreliable, features drift. If features drift, models behave unpredictably. If outputs are inconsistent, product teams lose trust. Business decision cannot be driven. So this is why the cross functional collaboration and domain knowledge are also part of data engineering skills and they are not optional. Data engineers constantly work with data scientists defining features, with product managers to define metrics, and a lot of partner teams to define their own business logics. This role requires constant collaboration and domain knowledge. Without understanding the business context, it's impossible to build correct data system. Now we have talked about the mindset. I am now going to talk about what kind of skills actually matter to be a successful data engineer, to go through interviews, get a successful job, and then become successful in that role. Right? So when we talk about skills, these are in the context of how they actually show up at the work. So don't think that it is a checklist that you have to go through. I want you to recognize these moments when they happen to you, right? So let's talk about the first and foremost and most important and foundational skill for a data engineer is SQL and data modeling. They are non negotiable. SQL and data modeling are foundational, everything else depends on them. Many serious data problems don't come from system failures, they come from incorrect assumptions about how the system works, how the data and their relationship works. A common example is, most of you already know, joins. A join that look very reasonable can silently turn into a many to many relationship, and it can double the amount of data that you are processing, creates incorrect data, right? Your pipeline, everything looks good, job succeeds, everything, your metric looks fine, but your data gets double because now you are joining instead of one to one or one to many to many because of a slight join incorrectness. That's why learning SQL, understanding SQL is by far the most important skill about SQL. Even if you go to distributed systems, even there SQL is heavily used by Spark to define any logic, any transformation, right? So that's why I ask people to make sure your SQL understanding is thorough. Every data engineer should think carefully about granularity, cardinality, and how metrics are defined. And you should know exactly what a row present, why a number has a value it does. If this layer is weak, every downstream system will inherit that weakness. So make sure your SQL and data modeling is thorough. You understand why a table is created, what data resides in them, how you can retrieve or interpret that data using SQL. Moving on to the next one, system understanding matters. System understanding means knowing how data moves through storage, compute, and time, not just how to write the transformation logic. A data pipeline is never just one job, right? It's a combination of trans your extraction layer, your transformation layer. Your transformation layer can also be into multiple jobs, then your loading layer, then you will have business logic, etc., and then you will create a visualization layer. You need to understand how the system works end to end, right? So generally whenever I see some issues, uh, I could tell the problem really comes from a single line of code. They come from how these pipeline interacts with each other. This matters because the same transformation can behave very differently depending on when it ran, how often it ran, and what guarantees this particular job or a system provides. I'll give an example. Many teams starts with a simple daily batch pipeline, right? Once a day, all data arrives, get processed, produce a clean and complete result. Over time, someone asks for a fresher data, more fresher data, say like, hey, once a day doesn't work for us. Can you give me hourly data, right? So, or near real time data. At this point, the logic might remain same, how your data travels, but the system changes completely. There is a huge difference in your batch processing versus real time processing. Now data arrive continuously in micro batches. Same record, some records will arrive late, some events will arrive out of order, some windows are incomplete, some, if you do not understand the system, you'll assume the data is final when it is not, and the result is number that changes over time for the same period. So your dashboard will look unstable, the data will be incorrect, incomplete, and team lost confidence even though no code is technically broken. This is why understanding of a system really matters. A data engineer should think about questions like, is this data complete when I processed it? What happens if data arrive late? What guarantees does this pipeline make to downstream users? They should understand what faster data is not automatically better data. and choose batch versus real time based on decision or business needs, not because of pressure. System understanding is what allows data engineers to design pipeline that behave predictably even at scale and complexity when it increases. Now, talking about the third point, distributed processing. In normal scenario, distributed processing only comes into picture when you have data at scale. Talking about Meta, Amazon, Oracle, these all process data petabyte scale or even higher scale every minute. Whenever your data processing increases the capacity of your single system, that's when the distributed reasoning or distributed processing comes into picture. You must have heard about Spark is a distributed framework. It relies heavily on SQL for processing, but natively it is very different than how a single processor, a single compute system behaves. So knowing distributed processing is a very important skill to be a successful engineer these days in current time, when data is everywhere and we are consuming um, data at the scale that have never done before. I'm not going to give you more about distributed processing, but because there are a lot of information available out there, but I am going to provide certain links that you can use to read about Spark framework, which is basically heavily used in all the industry. Okay, let's move on to reliability and data quality. Reliability and data quality means that the data behave consistently over time and can be trusted by the people who use it, right? Data has to be reliable and its quality has to be 100%. If your data is not reliable and the quality suffers, then there is no trust in data and no one will use it. So I hope we all understand how much to be a successful team, data engineer team or data engineer, it is important to provide a reliable and better quality results, which is data in any industry. This is what reality and this is what makes any business to help businesses to make decisions. If data is not reliable, no one will be able to make any decision based on it. Last but not the least, cross collaboration and domain awareness. This is very important. Data engineers sits in a place where they interact with software engineers, they interact with product managers, they interact with multiple domain specific partner teams, and they gather, capture data from all the different avenues. They need to collaborate with so many teams. Communication has to be good, and it is not an optional skill. You should be able to communicate a very technical information with a non-technical person. A financial domain person might not know what pipeline you are running, what job it is running, what complications you have, or what complex design you have, but you still have to explain to them why your data is corrupted, what happened throughout your pipeline. If you need some access or some source from them, you need to explain it to them in their own language. So you need to be able to understand business language, you need to be able to communicate with your partner teams in their language. So it is a very very critical skill that you can learn over the time. When you start framing your sentences, technical sentence, into non-technical terms, you can try to explain like you're explaining a 5-year-old to someone, and that really helps, explaining everything to your partner teams. So with that, I hope I am able to explain what kind of skills that any person who wants to become a data engineer should focus on. Now let's move on to industry expectations from a data engineer. There are three major industry expectations from where I can see. Um, First is own outcomes under ambiguity. Right? What does this mean? Basically, industry expects you to own certain things, certain data, certain outcomes, even when the problems are not clearly defined. No one is going to come and say, hey, this is a problem we are trying to solve, or give you the question that you can go and find the data and provide answer. You have to form the question with your own judgment, and then design a system that can answer those questions and much more than that. So that's where the ambiguity come, and then you should be able to, find your path through that ambiguity, but own the system end to end, to still produce the output. While going through that, you should be able to have, kind of, provide trust in your data, that leadership or partner teams, whoever is going to use your data, should put 100% confidence and trust in your data so that they will use it. If nobody is using your data, whatever pipelines you have created is not useful. And then the lastly, think in the terms of decision, not the pipeline. You should think about how your data is being used to drive certain decisions. I'm going to talk very in detail about each one of those in next 3 slides, but I just wanted to give you overview that these 3 things is highly expected form of responsibility of a data engineer. So I know the first one is probably the hardest adjustment, coming from school. In school, most problems are very clear. You are told what data to use, where it lives, what question to answer. I remember when I was in my master's program, we were told, go get this Twitter data set, and we want this model to come from this. So we know where to look for the data, what model we have to build. But at work, never happens. You will hear things like, this number feels off. We don't really trust this dashboard. Leadership wants more visibility here, and that's it. No data set, no instruction. At that moment, nobody's waiting for you to ask for a perfect requirement. What actually helps is stepping in and asking what decision this data set is going to affect. Who is going to use this? Where does this data come from? Uh, and ownership here does not mean doing everything alone. It means helping shape the problem instead of waiting for it to be perfectly defined by someone else. Some of the strongest data engineers I have worked with are not the fastest coder. They are the ones who bring clarity when things are messy. Once you start owning things like this, the next thing people really care about is trust. Trust is a big deal in data work. I have repeated many times over and over. People don't expect numbers to be perfect, but they expect honesty, and that honesty builds trust. When numbers change, people will ask questions. When they are usually not upset that the number changed, they are upset when no one can explain why your number suddenly doubled or tripled, or lower in count. A good data engineer should be able to explain what changed, what assumptions were involved, and they can say that this number has certain limitations. This is here is how you can use it safely. So basically, build a system that doesn't just say that your number is different. You should be able to understand, triage, track the lineage, and come to this conclusion that why this data is different, what caused the difference in data. When you get that understanding, that make you stand out in front of anybody as a very good data engineer. Over the time, people remember how you handle these moments. If you're upfront, you can build trust. If you hide things and don't really understand your own data, your own system, trust disappears very fast. Once trust is gone, even correct data stops being used. I have seen this again and again and again, that teams are generating data, but no one trusts enough to use that data. We are using resources, we are using compute power, and that data is just wasted. And when people see that, oh, this data is here, why we are not using it, it all boils down to no one trusts that data. Okay. So now with that, I hope we all understand how much trust and data quality matters for a data engineer. Okay, so even the trusted data still needs one more thing to be useful. That is decision oriented thinking. At the end of the day, data does not exist just to be moved from one place to another. It exists to help someone decide something. That is the part people often forget. A good data engineer is always thinking a step ahead and asking, what decision does this data support? Who is going to look at this? What will they do differently because of this data? If nobody can answer these questions, then even a perfectly built pipeline is not very useful. At work, you will notice something very quickly. People don't come to you excited about pipelines, they come to you when decisions are on the line. Should we launch this feature? Should we change pricing? Should we trust this experiment? Should we investigate this issue? Your work sits right under those moments when you start thinking the way your work changes. You stop building things just because they are technically interesting. You start building things that actually help people act with confidence. This is when data engineering stops feeling like support work and start feeling like impactful work. And this is usually the moment where people realize data engineering is not just about moving data, it's about enabling better decisions consistently at scale. Okay, so up to this point, we have talked about what data engineering is, how it's different from software engineering, what kind of skills matter in the industry. At this stage, people usually ask me one very honest question. Okay, but where do we start? How do we grow without feeling lost? And this is where most people struggle. They learn random tools, follow random tutorials and hope it adds up. So instead of giving you a checklist of technology tools uh, and hope it adds up, um, I want you to give you something more useful, a kind of a growth framework. A framework is not about becoming a data engineer in 3 months. It's about how strong data engineers are built over time. I call this framework scale because data engineers grow by learning how to scale meaning, system, and decisions. I will reveal one layer at a time because that's how growth actually happens. So, the first layer of my framework is scale. S. S is for semantics and data foundations. One important thing you should first remember that this is not about checklist. Before I start talking about each one of them, I want you to not feel this is a checklist that you have to go through each and every one in that sequence. It's just a framework that to help you guide to a proper growth as a data engineer. Anything can happen at any time, can happen in parallel, can happen sequentially, or even you can skip certain steps. Okay, so let's move on. Semantics and foundations. Everything starts with semantics. What the data actually means, right? This is the first mindset shift from software engineering. You are not compiling the code, you are understanding the data. You need to understand data and you need to understand what correct data means, what to do with null values, how to fill the voids, whether certain number can be zero, null, or certain numbers in it, right? You need to understand that basic uh, data for you to become a successful data engineer. If you can't read up a row in your data set and understand what it is telling you, there is no way you will be able to generate correct data. So understanding the data, understanding the SQL, understanding how the data model is built, how you can define the matrix, what is the meaning of this data and definition, and what kind of decisions you can drive from this data. That is my first layer of understanding. Okay, let's move on to the second one. The second one is compute and distributed system. Now you understand the data. How are you going to process it? You need to understand um, storage, compute, distributed system, what kind of tools is mostly used in the industry. Like I have mentioned, Spark, Flink concept. Only learning about Spark and Flink concept can take you a long way in the distributed system concept. And that will help you understand how partitioning work. When you are processing multitude of data in one go in cluster of computes, partitioning comes very handy. So learning about this whole piece and how it affects the cost and performance is very, very uh, important growth matrix for you. Okay, let's move on to the next one. Architecture and data flow. So you can see how data flows from one step to another. There is source of data, then ingest, then transform, then store, then serve. You need to understand this architecture and this whole flow because data doesn't fail in one job. As I mentioned earlier, data fails at from one step to another, right? And you need to understand the lineage, how data flows from one step to another to be able to properly see where there is a gap in your whole system. Okay. The fourth one is life cycle reliability and access. Now we have understand the data, we know how to process it, we understand the architecture. We also need to understand the whole life cycle reliability and access control for our data. You need to make sure your data quality is good, right? So learning about that, monitoring, how to enable monitoring. Data pipeline failure is not the right indicator of your data being correct or incorrect. The right indicator for a data set is how data differs from day to day. That is where your monitoring comes into picture. How would you backfill? How would you provide your access to anybody who needs to use your data? These are very, very important knowledge to become a data engineer. And then lastly, it's enable decision and communication. Okay, you have the data, you successfully created the pipeline, everything end to end finishes. Now what will you do? How will you communicate your data? How will you surface it to make a business decision? You'll be able to communicate, visualize, explain the change and drive the impact with cross functional team. So what I have seen using this, you have a clear picture of from one step to another how to grow, what you need to do to be able to do all of this and become a successful data engineer. And lastly, this is the end of my presentation today. I have added some resources to help you out with the scale framework or the skills that I have talked about. There are some, this SQL and data modeling, this data warehouse toolkit by Raf Kimball is a very, very good resource for learning data modeling. And then I have provided certain links. Using that, you can understand SQL, and I have also provided a link where you can actually do some hands-on coding that can help you interview prep for Meta and Amazon. They heavily use this hands-on SQL exercise. Then I have also provided certain links for Python to learn Python and do some practice, which is also again used by Meta and Amazon heavily to judge your coding skills. Then I have also added Fundamental of Data Engineering. It's a very good read. If you can read this book whenever you get time, that can definitely help you understand the entire data engineering and some very good interview related questions that can help you clear the bar and become a successful engineer. With this, I'm opening up for questions.
Thank you so much. That was an amazing talk, super helpful. If you guys have questions, feel free to put them in the chat, or you can use the raise hand feature on Zoom and we will call on you. Thank you again. We got a question if slides will be available to participants.
I can share the slides.
Okay, awesome. And then we're getting some questions in the chat right now.
Oh, you wanted to see the scale slide. I'll share the slide with all of you, Hitesh.
Yeah. And then I think we have a question from Zoe.
I'm still reading a question from Vincent that in future, do you think the job market for data engineering will decrease if AI could potentially take care of work of data pipeline and such? Not really. I've explained data is not about pipeline. Even if a pipeline is successful, data can still be wrong. You need human touch. No one can replace data engineering job, not in the near future. AI is not that strong. AI is depending on data engineering, maybe data scientist role to some extent, but data engineering is the core grunt work. No one can replace it in the next 10 years.
Cool. And then Zoe, if you want to ask your question, go ahead.
Yes, thank you so much for the great presentation. I wanted to ask about data standards and if you have dealt with any interoperability standards or any kind of data standards and how it applies to your job.
See, every team, every company has their own set of data standards. There is GDPR, that is globally accepted data standard, that is different for European countries, that every company has to abide by. There are policy about that. But when it comes to data standard, it's basically derived from your source data, what you're trying to do. But I think that's about it. There is no particular data standard that you can apply. If you're asking about data formats, there are several different type of formats available, like Parquet, Avro, and that can help you interpret the data in a processing time frame where you don't need to define schema; it can infer. Were I able to answer your question?
Yes. Yes,
Yeah,
thank you.
basically, I'm trying to say that there is no particular standards. The data standard depends on your team, your company, and what kind of data you are processing.
Got it. Thank you.
Okay, I'm reading a question from Fuhan. Um, Sorry if I'm not pronouncing your name right. What are the ways to improve your ability to spot issues in a pipeline? Various different techniques, right? If your pipeline fails, you can simply check the logs where it fails. From that point of failure, you can spot the issues. If your pipelines is not failing, but it is not processing at scale, it is slower, it's performance related issue. Then you will go look at your query planning and see why your data is taking slow. Suppose I'm processing a petabyte of data and it is taking me a day to process. It's a performance issue, it's my query planning issue. And then I will go read the query planning and see, okay, maybe I'm doing multiple scans of the same data set. I should change it and I will change my query planning. Maybe you're trying to collate all the data into one big data frame that is making your pipeline slower, so I will try to partition it by something else. So there are various different techniques, all depends on what you are observing, the what kind of behavior you are observing in your pipeline. Is it a failure, is it a count mismatch, it is a performance long running, it is a scale issue. Depending on that you can, so these are the things to notice. Like, you can just check why it is taking long, and reading a query planning, do execute commands, explain commands to understand what query you are running, can give you a hint of why your pipeline is behaving this way. um Are there projects, sorry, I'm reading Sophie's question. Are there projects, type of projects you would recommend to get some hands-on experience, or in is practice more important? See, generating pipeline, I don't see the how practice is going to help, but yes, understanding the data and how you can move it from one place to another helps. But you can use Twitter data set, and honestly, after that, I am not really sure what other data sets you can use. They're readily available, but the main thing you need to understand, what is the amount of data that you are going to process, and using which technique you are going to process. Are you going to build an ETL model, or you are going to build a distributed processing model? Depend and understand your data. You can use Google to get your hands on many different type of data sets. Try to read one row at a time and try to understand what this data is telling you, what this one row mean to you, and then you decide how do you process. There are multiple frameworks, right? ETL, ELT, distributed frameworks. Then slowly you will build up, like, is ETL more helpful than ELT more helpful? Is distributed processing more helpful, or batch processing more helpful? So that is my recommendation. Okay, from Anjani, if an individual is building dashboards, sourcing data from a various sources, not through building pipelines, but importing them to BI tools and process it to build views, insights, what do you think? How far an individual is to be considered as a data engineer? Very good question. Basically, what this person is doing is business intelligence work. There is no data engineering behind this, because what you are doing is basically using a data and creating a visualization for it. There is no data cleaning, there is no data cooking, there is no data processing. That is the core of the responsibility of a data engineer. Yes, data engineer also do this piece, but at the very end of their spectrum, right? Once they have captured the source data, they have transformed it to make it a usable form, that's when you can plot it. So hope the distinction is clear, that it's mostly a business intelligence or data visualization developer's responsibility, what you have described.
I got a private question saying that if someone can't find internships, what is a good way to get experience in this field and kind of get some resume ready projects?
See, if you can't get internship, I would say you can still do observerships with, small companies who are looking to, give you some experience without paying you. I have seen that happening with observerships that is available. You can still apply. Internship is not a first point of entry to any company. You can still apply as a fresher, as a graduate student, directly to the company portal, and you can go through the interview process as everybody else. These are the only two things I have seen in my experience working, if you can't get through an internship. I know these times are very difficult with internship and all, but the jobs are still available. Don't get hung up on FANG companies or this company or that company. Start applying, start interviewing, start gaining experience. Anywhere it matters. Experience matters. Company name and title doesn't matter.
Awesome.
Okay, what transferable skills did you find the most helpful, useful to have when making a transition? Oh, very, very, very good questions, Stephanie. I have been through various different roles throughout my career, from UI engineers to backend engineer to data visualization to data engineer and now manager. The most important skill that you can have is the ability to communicate the requirement clearly, to be able to collaborate with different people, and to be able to explain people in their own language where they can understand. You should be able to talk to a leader or leadership, VP, SVP, or you should also be able to talk to an intern who is very new to this field. And you should be able to change the way you communicate the same thing, and the way you ask questions, and try to dissect the requirement into multiple steps. It can take you long way, whether you are a data engineer, software engineer, or any. See, coding skill, anyone can learn it. Now you can even write code through AI. So I would not say coding is a transferable skill. Thinking SQL like a normal language, just like English, that is a very good transferable skill. This learning SQL can be applied to data engineering, business intelligence engineering, data science, product management, program management, you name it, SQL is being used, right? So you should be able to read SQL like it's a normal English. That's how proficient you have to be with SQL and Python, if I can say. So these are the, soft skills are basically not soft skill for data engineers, and SQL, Python are very, very core skills, which is transferable to any kind of role.
Awesome. Thank you so much. That was very helpful. If you want to put the link of the slides in the chat so students have access to that.
How about I have to transfer it to Google Slides. I will send the link or send the PPT to you, and would you be
Okay.
able to share it with everyone else?
Yeah, sounds good. So I will share the slides with everyone else. Thank you so much again. We have another talk right after this, so